So let's start. So today we'll talk about the input language of Clingo. So recall what we had before. So what we are going to do in the so-called answer set programming is we are going to solve the problems, but not by writing the traditional or procedural programs, but we are going to use declarative programming, and that is called answer set programming. So the basic idea is to formulate the problem into an answer set program where you use answer set solver to find the output and interpret this output as a solutions. Now when we give this problem to computer, we are not describing how to solve this problem, but we are going to say what problems to be solved. Okay, so in the other problem programming, you usually have to first think about what is the problem to be solved, but you have to design how to solve it, what is the right data structure, and what is the right algorithm to use. In here, we are not going to do that. Okay, so let's start with a simple example of, let's say, database query. So database can be considered as a table, and you have the columns, okay, and the values. So this table is a very simple example, just to illustrate the main concept. So we have 4 countries and their population in millions. Okay. And what we want to ask the system to return is about the largest city. And we have to tell this system how do we define this largest city. So a country C is large if the population size of C is S1 and the population size of the UK is S2 and S1 is greater than S2. So in simple English, it means that a country is considered large if it has more population than UK. Okay, so this is what we want to ask computer. Now, note here that this is not a command. Okay, it is a declarative sentence explaining how we understand large country. So how do we do this in Clingo? The table can be viewed as this set of facts. Okay. Is it similar to propositional logic, where we can assign truth values to atoms? So here we say size of France at 65 is an atomic unit that we assign true or false. So when you write this one, it means it's true. So size of France is 65 million. Okay. The second column, Germany 83, can be, of course, written in this form. Okay. Same as Italy, which has 61 million, so size of this, and so on. So as you can imagine, if you have more and more entries, you can write these fact. Okay. So that is good. So data can be easily represented as a simple list of these fact. How about the rules? So the rule that we wanted to express is this one. How do we write? In the language of Clingo, you write this one line. And something that I want you to learn in the next couple of lectures is how to translate the English description into the language of Clingo so that Clingo can answer for you. Okay? And these things, the syntax of this language actually came originally from Prolog, but it also has different constructs. So if you know Prolog, you may see something similar, but for this class, I'm not requiring you to know about Prolog. Okay? So this symbol, colon dash, is called if in English. So it's like an arrow in propositional logic, just written in backward. And this rule seems similar to implication in propositional logic. Okay, if it is an implication written in backward, we are going to read as size of C is S1 and size of UK is S2 and S1 is greater than S2. Then this implies that C is largest city. For this class, probably it is actually easier to read from left to right. So we define larger of C if these conditions on the right-hand side is true. Okay? So we say a city is large if, so I'm just reading it, country C is large if the population size of C is S1 and UK size is S2 and S1 is greater than S2. That's what the English statement is saying. Okay, now if you give these two lines to Clingo and find the answers, then Clingo will return this set of atoms. So in the language of Clingo, we call something stable model. Instead of just model in propositional logic, we say stable model, also known as answer set. If time permits, that we are going to study what is the difference between stable models and the models that you learn in propositional logic. But for time being, you can just think about as intended models of this program. And it makes some sense if you look at it. You see that first 4 atoms here is same as what you are given. So you already told the Clingo that this is the size. But also, the new things coming out, so larger of francs was not occurring in the given rules. But now it is deduced from the rules that you have. Okay? And same for larger of Germany. And of course, it makes sense because if you just informally argue that France has 65 and UK has 64, okay? And 65, so if you see is France, it's 65, and 65 is greater than 64. So France is considered as a large country. Same as Germany, because Germany has 83 million population. Okay? So let's see how we can query this. So if you download Clingo from the Potasco page, you can execute this in a command line. So if you use Mac like me, you can open the terminal, okay, and go to the directory that you want to write the example in. If you have Windows machine, then you can also open the command shell, do the same thing, okay. So hopefully you understand how command line instruction can be executed. If not, let me know or post on the Piazza so we can help you on that. If you have installation problem, just come to see us, one of us. We can help you how to download and install on your computer. There is also the web browser version, which is okay if you don't know how to deal with those things. But I recommend you to actually download because that gives more flexibility. Okay, and sometimes I will ask you what is the command line that you used instead of clicking the buttons in the browser. Okay. All right, so this one, okay, I saved it in a simple.lp file. So .lp is an extension that people commonly use, but you don't have to use the same extension. It's just a convention. It is okay if you use different extension like txt or even no extension, Clingo will still work. Okay? And here I wrote those 2 lines. Actually, instead of 1 line, I actually break those lines into 4 because that looks more like the data here. Does not matter in terms of Clingo. You can put these lines into 1, okay, or multiple lines, okay. Usually, the period tells the Clingo where each line ends. So here, you see that period at the end of each line, okay. All right. So then, how do we execute the Clingo? It is simple. Just type Clingo and the file name, okay. So Clingo returns these models. Actually, let's see. Okay, so Clingo returns this. Okay, this is actually the output. I use Clingo version 5.2.1, but probably right now is more than that, or more up to date than this one. It does not matter as long as you use Clingo 5. So here, Clingo prompts that it's reading from this file and solving, and the answer is this. So this is called answer set or stable models that Clingo returns. So there's only one model and one call, and this is the time that is spent, and CPU time is this. Some statistics. Okay, of course, this is a very simple program, so it's, of course, very fast to compute. Okay, so this is how to run the Clingo. Okay. So in the textbook that I posted on the Canvas, you see a lot of exercise problems. And we are going to talk about some problems here. And the nice thing is actually the textbook also has put most of the solutions at the back of the book. So if you don't understand by yourself, you can find some solutions at the end of the textbook. Okay. So here, the population of Russia in 2015 was 142 million. Add this fact to your file and check how this affects. So what would you expect? What can we do here? So this is simple file, right? Now we have Russia. And it was 142 million. So we just add fact. Okay, and then call Clingo. And Clingo will now say Russia is also a large country because 142 is bigger than 64, the UK size. Okay, so you got a new information. As you see, if you have more data, you can just add it. Okay. The next one. Instead of comparing countries with the UK, let us define large as having more than 500 million people. How do we modify this? Again, you can go there. The line to modify is here because now we are talking about the size of UK, but we don't want this to be compared. So we don't care about it. Okay, so we just turn into 500. Okay, so the rule, as you can read, the country C has size S1, and S1 is greater than 500. Okay, actually none of them has that. So probably Clingo will return nothing. Okay. So in here, you don't see any large city. It has only the database fact. So each of the country and their size, but none of the cities are large. Okay, any question up to this part? Okay. Okay, so now let's look at another example. Again, this is a very simple example, but gives some idea. So we consider a rule that child of xy if parents of yx. So you can read it in English. So part A, how do you translate this rule into English? Okay, so you can say x is a child of y if y is a parent of x, right? You don't have to follow what I just said. You can also say x's child is y if y's parents is x. That's also another reading to do, which is actually opposite to the original. But it doesn't matter. Okay, so let's just fix the interpretation. When you say child xy, let's say x is a child of y. Okay, let's read in that convention. So now, if we run Clingo on this program, what will be the stable model? So this is the database fact. But now this database fact will make some new facts to be derived. Because parents n Bob is true, so that means y is n, x is Bob, then we can say that child of Bob, comma, n is true because it is derived from this one. Okay, and same for the other things. Okay. We can also test this in Clingo. If I have it here, okay. So this is the rule that you saw before, okay. And I say Clingo family .lp. So as you see, it will return these solutions. So this was the fact that you gave to Clingo, but also Clingo derived the child relationship based on the parent relationship. Okay? Okay, so that is the introduction, and let's now talk about something more detailed about each of these constructs. So the first thing is about the rules. Okay? And I'm going to deliberately be informal when I describe these rules, okay? Because there are many, many constructs that we can add, and if we try to explain everything and then start programming, that's too much. So what I'm going to do here is to introduce constructs one by one so that you can actually understand. There is actually a big, deep theory behind all this language, but I'm going to postpone that to the later. Okay, so I want you to write a program fast, okay, before you need to understand everything about the internals. Okay, so in Clingo, or in answer set programming in general, there is a rule. And this rule consists of head and body separated by the if symbol, which is the colon dash, and with a period at the end. So this is the rule that you saw before. Okay? Now, some rules do not have if, as you saw. Okay, so this is just a fact. Now, what can appear in those rules? If you look at these rules, it has certain structures. Okay, so these things, a large of C, size C, comma S1, size UK, comma S2, it's like an atom in propositional logic. Okay, so we'll just call them as an atom. There's also something about comparison, which is not atom. Okay, so we'll just call it comparison. So rules contain atoms and comparison. Now, if you look at atom, okay, you see that the atom starts with some constant, some symbols like large, followed by the parenthesis, okay, and it has some argument. Okay, in general, these predicates, these symbols that occur here are called predicate symbol, and they usually represent a property or relation. Okay, so this large here is a property about the country being large or not large. Size is also some property, or you can say a relation between the country and the number of people there. Okay, so population. So it is a relation between country and its population. Okay, now some of the atoms you will see may not have any argument too. So it is actually fine you write something like small without any argument. That is also possible. Okay, so this argument is kind of optional. For the comparison, we have these symbols, okay, and the first two symbols apply to any things, okay? So you can say John is equal to Mary, or 1 is equal to 2. You can compare any possible atoms, any possible objects. While these last four is only about the numbers, because it doesn't make much sense to compare something is not a number. Although actually I should say Clingo does something more than what I just said, so it may also compare some non-numbers too. Okay, but the usual way to use these four symbols is when you use it for arithmetic or the number comparison. Okay. All right. So now, if you look at this simple program that you saw, there are three kinds of symbols appearing. So first is called symbolic constants, like size, francs. Okay, so this is alphabet symbols. So they are the symbolic constants. There's also a numeric constants, which is like 65, 83, 61. There are also variables like C, S1, S2. Okay, so there are three kinds of symbols that occur in atom or comparison. And you can distinguish which is which by looking at the first character. Okay? So numeric constant is an integer, so its first character must be a digit, or maybe minus sign. A symbolic constant is a string of letters, digits, and underscores that begins with lowercase letter. So if you see a lowercase letter or the underline, then this is symbolic constants. A variable, like C or S1, they start with uppercase letter. Okay? Now, the difference between symbolic constants and the variable for this, let's say, UK versus S2, UK is a specific objects, right? While S2 is a variable that ranges over possible objects. That's the difference. Okay? It's like a constants and variables in user programming language. Okay. Now, what appears inside an atom or comparison are called terms. So those terms occur as an argument. Okay. So like the UK or S1 that you saw in the previous slide, they are called terms. And when we say some atom or rule or any kind of syntactic expression in the language of Clingo, we say ground if it does not contain variables. Okay, so this is a terminology. And when you say a fact is a ground atom. So size UK comma 64 that you saw, that's a ground atom. So that's a fact. The database fact that you saw, those are the ground atoms. Why that makes it some notable distinction? Because when you have a variable, the variable can range over different objects. So you don't know which one that the variable stands for. Okay, but if there is no variable, then you know what it is. Okay, so, and you can say that whether this is true or false. Okay, so when you saw this example already, okay. Now so the C, S1, S2, they actually range over possible instances. So we can get a ground instance by substituting ground terms for variables. France is a ground term because it does not contain variables, so it substitutes C. C is a variable. This substitution occurs when you substitute terms for variables. Okay? So France, so if you have this one, this is the original program, and it may contain many ground instances, but one of the ground instances is this one. When you replace C with France, okay, and S1 with 65, and S2 with 64. Okay? Now, one thing to be careful is when you ground it, you have to replace the same variable with the same instances. If you use C here, then and you replace this C with France, then every other occurrences of C must be replaced by France. That makes sense, right? You use the same variable, you're pointing to the same thing. Okay? Okay. So this is an instance. Now let's look at this exercise. So if you have this program that you saw, what is the substitution that makes larger of Germany to be true? So as I said here, you don't see Germany, right? There is no occurrence of larger of Germany, but when we printed out the stable model, it was the large Germany is one of the atoms that are true. So why Clingo think large of Germany must be true? So to do this, obvious choice for C is Germany, right? So C is Germany. And so this C must be also Germany. So we have the size of Germany 83. So then S1 is 83. And UK S2 must be 64. Okay, so 83 greater than 64. So everything here is true. So large of Germany should be true. Okay. So here, of course, C is the Germany. S1 is 83. Okay. and S2 is 64. And of course, 83 is greater than 64. So everything on the right is true, so larger of Germany must be true. Okay, let's look at another example. So child of xy if parent x. This is the family relation that you saw. So which instances of 2.1, 2.1 is this rule, justifies including child then Bob, then comma Bob in the stable model. So to do that, x must be then, y must be Bob. So that means parents of Bob comma then must be true, and that is actually true. Right? So just replace y with Bob, x with then you will get child of then comma Bob. Okay? All right. Okay, so quiz time. So let's actually do this one. So this is 1.1 is the only rule that you are given, and I'm asking you which of the following ground rules are instances of rule 1.1. And why is not working? Weird. Okay. All right. So this is short answer question. Let's start. So you have to choose all that are true. So the next homework will be about programming in the language of Clingo. Okay. Interesting. So this is the solutions that I received, and lots of differences here. So A, C, D, B, C, A, B, C, D, C, A, C, B, C, D, B, and C, B, and C. So B, C seems to be the majority. There's also A, B, C, D, and so on. Okay, interesting. So let's look at this together. The first one, which of the whether this is the instance. So in order to do that, C, if assuming that's true, C must be France, right? So that is good. So France 65, okay. It's a possible instance. I don't know whether France is as 65. That does not matter, as long as you replace S1 with some ground terms. But this is actually the problem. UK cannot be replaced by Italy. I told you the substitution is only for the terms for variables. You cannot replace the terms for terms. Okay? So this is false. A is false. It's not a ground instance. What about B? Well, for B to be true, C must be Italy. Okay, that's good. S1 is 61, that's good. You have UK, I don't touch UK, that's fine. 64, good. And S1 was 61, so I use same 61 here, that's good. 64 here, good. So I don't see any problem here. So this is one of the possible ground instances. What about the next one? Well, next one has Italy, okay, so the difference is only about 83, does not matter, right? As long as you replace the variables with terms, that's okay. What about this? Large of 7, size 7, 7, okay? So again, the thing is you're going to replace the variable with terms. So 7 is a term, so you can replace the variable C. Although it doesn't seem to make sense, according to the definition that we just studied, that is okay. So size 7, 7 is fine as long as we are using this substitution in a consistent way. Okay? So it's actually D is also true. Okay. Now, these are all instances. Of course, some instance may not make much, it doesn't actually affect the solution much, because if you don't show that size 7, 7 is true, none of your data is saying that size 7, 7 is true, this rule simply doesn't work. It doesn't generate larger of 7. There's no way that this rule can generate larger of 7, but that is okay. According to the definition of Clingo, it doesn't care, okay, as long as you replace the variable with ground terms. Okay? So the answer was B, C, and D. Okay. And the next one is, I told you just now that you can even compare something with non-numbers. So it looks like this does not seem to make any sense. Abracadabra is greater than 7. Okay. This is actually true, because if you just look at the Unicode, the letters are after the numbers, right? So based on that, this is actually true. So if you ask Clingo to do this, let's actually try that. So P is abracadabra. Okay, so it returns P. So you see the P answer there, right? But now let's actually change it. If it is less than 7, and if you ask Clingo, it says there is an answer, but nothing is shown. Nothing is shown, which means that P is not true there. Okay? So you can actually compare these things. And there's also, so any term has some total order. You can actually compare between the terms. And Clingo has a minimal element and a maximal element, and they are denoted by infinity and supremum. Okay? Infimum, actually. So this is probably the smallest value, and this is probably the largest value. It depends on your programming. You may need these values or not. Okay? Now, something else. So let me ask you, based on your intuition, if I give this to Clingo, what will be the stable model that will be returned by Clingo? Anyone can guess? Oscar, can you guess? What should be the stable model if you give this one? 8, so P of 8, right? Okay, how about P of 9? Can this be true? It is, right? Because 9 is greater than 7. How about P of 10? 10 is greater than 7. So what is the stable model? It could be P of 8, 9, 10, 11, and so on. Now, in theory, yes, that's the stable model. However, when you try to do this in the Clingo, Clingo will complain. Actually, let's check it, because I don't know. So this is the program that you saw. Okay, now Clingo give an error message, and it contain say unsafe variables in this, and note X is unsafe. Okay, I'm not going to explain what we mean by unsafe now, because the definition is a bit more complicated. But just to give you the reason, this means actually, as the title says, the stable model here is infinite. And Clingo cannot show infinite stable model. There's only one stable model, but this one stable model has infinitely many atoms that are true. P of 8 is true, P of 9 is true, P of 10 is true. And this is way too much. I mean, Clingo will never terminate printing out this. So in order to avoid that, Clingo says, I cannot give you the solution. Okay? So when you do the programming in Clingo, maybe not exactly this rule, but you encounter the case that the Clingo say unsafe variable. You have to suspect maybe there is something, it's not wrong in the logic, but maybe you are asking Clingo to generate infinite stable model. Okay? So maybe that's the bug that you didn't have in mind. Okay? So as I said, the algorithm used by Clingo for generating stable models are not applicable to programs that contains rules like this. Okay? And it says unsafe variables. Okay? So roughly saying that X is unsafe. You cannot make finitely many values for this X. That's what Clingo complains. All right. The next one is about the pooling. So this is just a syntactic sugar. When you have a group of facts with same predicate symbols, you can actually make it a bit shorter. Okay. So for instance, we wrote this database fact, and we repeated size, 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 size. Okay, it's a bit tedious to write, so you can write this in terms of just one predicate symbol size, but followed by the argument. Okay, so francs, 65, and then you use the semicolon to denote the separator. Okay, so what Clingo does internally is when you write this way, it will turn into this form. Okay, and sometimes, so this is called pooling. So pooling together. Sometimes this gives shorter expressions to write, so which you may want to have. Okay. So if you run Clingo on this one rule program, so this is one rule, but it actually has 4 facts: P1, 2, P2, 4, P4, 8, P8, 16. So there will be 4 atoms in the stable model. You can try. I'm not going to show every run here. Okay. Directives and comments. So again, this is some convenience. When you write a big program, what happens is the Clingo returns so many atoms. So far we have very simple program, but when the Clingo returns maybe thousands of atoms, you do not want to see all of them. So you can actually tell Clingo to show only the necessary things. Okay. So this is show directive. So directive starts from this pound sign and the command. And this is the predicate symbol. And you see the dash, you see the /1. This one represents the arity, how many arguments are in this large. Okay, so we have large of C. That's large has only one argument, so that's why we put 1. Okay. If you omit 1, that is also okay. Clingo will try to return all solutions that has large in there. But sometimes you see that there are 3 different P's here, but they are all different P's. Okay. So here we have show P slash 0, show P slash 2. Okay, so what will be the solution? What will be the stable model that will be returned here. So Alex, what do you think? What will be the answer here? I mean, we are just saying that show P that has no argument, show P that has 2 arguments. Okay, so it will show only this one and this one. It will not show this guy because we didn't tell Clingo to return that. Okay, so when you use show command, all the other atoms are not listed here will be suppressed. It will not be shown. Okay. All right. The next one is const. So in the previous example, we had this UK as kind of the standard to compare. However, we want to also change that. So this is kind of denoting the placeholder. Okay, so we say C0 equals UK. This is in the file. Okay, so whenever Clingo sees C0 in the command line, I'm sorry, not the command line, in the file, it will think C0 is same as UK. Now, the advantage of this representation is if you want to change the standard to another country, you just need to change here. C0 equals US. Okay, that's also fine. Okay, then you don't have to go through the other currencies of the countries that was a standard country. This C0 change to another country will replace all possible occurrences. And you can actually do this in a different way. You can actually give command line options. So dash C, C0 equals UK. You can do that too. Okay? So let's actually look at example. So this is the, one of the files that you saw, large.lp. Okay? So we have show command line here. Okay? And as you see, this was UK before, but I put C0 now. Okay? I also write this one here. So this is another file, large input.lp. And I put this database fact into another separate file. And here I said const is C0 is the UK. Okay? So if you have this one, this UK will be the reference country to compare. However, you can also change that. Let's say it could be Italy. Or let's say France. You can actually use 2 files, or actually as many files as you want as an argument for this Clingo. So Clingo will actually merge these 2 files and show that. Okay. So since we changed the reference country to, was it Italy or France? Okay. So now we see only the Germany is the largest city. France is no more large because it cannot be larger than itself. Okay. Okay, the next one is actually a very simple thing. It's a comment which helps you to remember what rule that you wrote. So if you use the %, then whatever that you have that line until the end of the line character, that will be considered as a comment. Okay, so it will not be processed by the Clingo. Okay, so this is the file that you saw. And as I said, you can actually put this file together as an argument for calling Clingo. So you can write the list of file names there. But sometimes you want to have only one single file which include another file inside. And for that, you can use this command, this directive in one file. So if you have a large.lp file, okay, so this is the rule file. And if you want to include this inside, so what you can do is you can put maybe pound, actually, yeah, you can put pound include, and then this file name, large input.lp here. Okay, so you can include this line in the first file, then you don't need to call large input.lp because that will be included when you load large.lp file. Good. Any question up to this part? All right. So let's do arithmetic. So in the language of Clingo, these are the symbols that you can use to build a more complex term. So you can use addition, multiplication, double star is exponentiation, and slash is division. But note that this is called integer division. Okay, so Clingo does not work with real numbers, although there are some extensions of Clingo that handles the real numbers. But in this class, we'll focus on the integer arithmetic. Okay, so what that means is when you have a remainder, Clingo will be ignoring that remainder. So for this 4 divided by 3, Clingo will say 1 instead of 1.333. Okay, so when you use integer division, you only look at the quotient. The Clingo returns the quotient as an integer, okay, and forget about the remainder. If you use the backslash, it is actually opposite. Clingo will return the remainder. So what is 4? If you write 4 backslash 3, what should be the Clingo return? 1, okay, because when you divide 4 by 3, remainder is 1. Okay, and you can also use absolute values. So if you write -3, this returns 3. So these are the symbols that you can use. Okay, now let's look at the example here. So this is a one line, p of n comma n squared plus n plus 41. Okay, if n is 0 dot dot 3. Okay, now here there's a new construct that you see, 0 dot 3 are called intervals. So n will be ranging over 0, 1, 2, 3. Okay? This is a typo. I meant this to be 3. Okay? So basically it is computing the polynomial. Okay, the first argument is the value of n. And the second argument is the value of the polynomial n squared plus n plus 41. Okay? And it asks to Clingo to return the polynomials when n equals 0, 1, 2, 3. Okay? So actually, let's play with that. So this is the one line that you saw. Okay, so n squared p is a relation between n and n squared plus n plus 41. Okay, so if you call Clingo, Clingo will return the first 4 values of the polynomial. Okay, when n equals 0, 41, 1, 43, 2, 47, and so on. Okay. Of course, it does not matter. I mean, this is just for simple illustration, but you can write as many values as you want. And let's see how Clingo returns. Clingo returns all these polynomials. And as you see, it's pretty fast. Okay, this is not a very complex computation. Okay. All right. Now the question for you. Let's look at A. Okay. So what will be the Clingo's output if you give A? Okay. So let's change it. So let's think about this. Okay, I'm talking about the first one. Don't do the second one. Okay, so if I give for first one, then what should be the return value of Clingo? All right. Looks like this is a more difficult problem than before. Okay, so what is the difference between this problem and the previous one when n goes from 0 to 3? Before we had n equals 0 dot dot 3, while here n plus 1 equals 1 dot dot 4. The difference in the n, there's no difference. So the output is actually the same as before. So n still goes from 0 to 3. Okay, so the answer is actually the same as the previous one. For B, you see that n goes from -3 to 3. However, the second term here is, second comparison is saying that n is also greater than or equal to 0. So the values of n that satisfy both two is still 0, 1, 2, 3. So the output is again the same. Okay, if you don't believe me, you can use Clingo to verify this. Okay, so here is one way that you can make it more general. So here, before you had a particular polynomial to compute, but I want to compute any polynomial, n squared plus bn plus c. Okay, this is called standard form. Okay, in quadratic formula, right? So how do we write this thing in Clingo? Instead of just particular values of A, B, and C, we use the placeholder that you saw before. In the command line, we can give dash C, A equals 1, B equals 1, C equals 41. That is asking the Clingo to find the same polynomial as the previous slide. Okay, so n squared plus n plus 41. Okay, and dash C, n equals 10 means n, the capital N goes from 0 to 10. Okay. Alternatively, of course, you can put the const directive in the file, so saying that what are the values of A, B, C, and n. You can do that too. Okay, so one thing that I told you before was Clingo knows only about integers. So the output should be only integers. Sometimes when you give the computation, then it looks like you need real numbers. So then Clingo actually forget about all the real number values. It will only return the integer solutions. Okay? So let's practice this one. So if I give you this problem, what will be the output of Clingo? Think about it. So there are two variables. N goes from 1 to 4, and n is also 2 times m. Okay, so what could be the return value of Clingo? Okay. Some student didn't do yet, but let's see. Okay, so these are the answers. M, 2m. Okay. Error, or all these. I told you just now that Clingo doesn't deal with any non-integer numbers, right? But you still answer that way. Okay. So let's actually play with Clingo. So what is the value? Clingo returns that 1, 2 and 2, 4 is there. Why? Well, there are more values of n. Why it does not return that? So why those two? If you look at it, n goes from 1 to 4. 1, 2, 3, 4. In this case, n equals 2 times m, meaning that m is actually half of n. So when n equals 1, m must be 0.5, but 0.5 is not a valid value that Clingo can return. So that atom will not be produced. Okay? So Clingo will not output 0.5, 1. This is not a part of the solution returned by Clingo, because it only returns integers. For 1, of course, half of 2 is 1, so Clingo will return P 1, 2. For 3, again, same reason, it will not return. For 4, n equals 4, half of that is 2. So Clingo will return only these two atoms. Okay? All right. So previously, we saw that the intervals are used in the body of the rules, but you can also write the intervals in the head. Okay, so P0 colon dot dot 3 means that you actually write these things. So P0 is true, P1 is true, P2 is true, P3 is true. This is actually quite handy. You will realize when you do the programming instead of writing these many, you can just write these intervals. So the textbook author actually used a lot of examples of using these intervals in the head. Okay, that makes the encoding quite succinct. And of course, these can be shortened using pooling tool because they have the same relation symbol, predicate symbol. So you can just 0, 1, 2, 3, use pooling. Okay, so sometimes you can use either intervals or pooling. Although there are certain differences. Interval can be used when you have integers. When you have numbers, you can use integers. Okay, you cannot use dot dot for the other symbols, which are not integers. It does not make any sense. P of John dot dot Mary does not make any sense. Okay, pooling can be used for both numbers and non-numbers. Okay. Okay, 2.8. So using the things that you learned so far, can you write one rule program, okay, to generate this same stable models as this one? Okay. So here the constraint, you have to use only one line, okay, to generate this as a answer set or stable model. But you should not use pooling. Can you do that? Anyone? Any volunteer? I can offer the participation credit too, if you can write only one line of the code. Yes, Riley. Yeah, come here. Okay, so while Riley is working on that, let me ask you another volunteering question. So again, use only one line to generate this as a stable model. Any volunteer? So 0, 1, 1 minus 1, 2, 1, 3 minus 1, 4, 1. Okay, so the first argument increased by 1, while the second argument is alternating between 1 and minus 1. Can you write such a program in one line? This is it. This is another. Okay, are you done? Let's look at the solution. Can you explain?
It's the exact same as what we just did. So it only returns integers. So when n is 1, m can't be anything. So when n is 2, factor of 2, then it's going to return a integer m, which is 2, 4.
Okay, so the idea is similar to the previous one. So let's try that. N equals 1 to 16, and m equals 2 times m. What is it? N equals. Did you have n or m? N equals 2 times m, right? Okay, so let's see. Does it generate the same solution? There's a problem here, right? It's supposed to generate powers of 2. So 1, 2, 2, 4, 4, 8, 8, 16, but it has actually more than that. Okay, so sort of work, but doesn't completely capture. Anyone? The reason is actually you have to have a power of 2, but it's only divided by 2, so it does not work that. So let me actually show one way to do. Basically, you use the power. So what is going on? It has two arguments, okay? And n goes from 0 to 3. Okay, the first argument is 2 to the power of n. The second argument is 2 to the power of n plus 1. Okay, so let's see whether this can do. So it generates the thing, right? So here, the first argument was going from 1, 2, 4, 8. Again, it's 2 to the power of n. The second argument is 2 to the power of n plus 1. So you can just write that way. What about this guy? So it has to go from 0 to 4. So you can see that you have to introduce one variable. The first argument should go from 0 to 4, right? That's fine. But the second argument is alternating between 1 and minus 1. So how do we write? Anyone knows how to do? You can? You want to write? You happen to? Okay. You have credit, right? You already have one credit, so maybe let me give you. You don't have it, right? Yeah. Oh, you don't have it? Okay. I don't know. Why don't? But you have participated already, so let me just give a chance to new guy. Okay. So why don't you write solution? I can actually offer you another problem too. The next one is actually this one. Can you generate this kind of pyramid? Okay? Just write one rule program that generates this. It's like a programming contest, right? Okay, so ACM programming coding test, you have to generate this kind of thing in a star shape or whatever the shape, right? So maybe you can think about that kind of competition here. Anyone for this problem? You want to do? Why don't you? Okay, so why don't you write your name? And okay, so and let me actually type in because that's the best way to check. So can you tell me? No, don't go yet. Okay. So yes. N. Zero to 4. Oops. Syntax error. Do you know why? Actually, let's actually look at the error message. Syntax error, unexpected EOF, expecting this. My mistake. Period was missing. Okay. Okay, so 0, 1, 2, 3, 4. Good, thank you. We don't have the TA today. So Thomas Chilton, okay? So if I don't remember your name, remind me later. Okay, so did you write your solution? Okay. This one. Oh, sorry. I have to go here. Okay, so let me type in. Can you call? Are you done? Can you tell me what to write? I cannot see, so that's why I'm asking. M? Can somebody read for me?
M is greater than or equal to 1,
1.
period. M is less than or equal to 4, period. N is greater than or equal to 1, period. And
N is greater than or equal to 1?
yeah,
Okay.
period. And then N is less than or equal to M.
Okay. Huh. This is a problem. Okay. So Clingo say that this might generate infinitely many stable models. Unfortunately, actually, we are out of time. So so actually, you can go to the Clingo and test your idea. I want you to actually, there's a solution at the end of the textbook I said, but try to do this by yourself. That will help you to hone your programming skill, which will be helpful. Okay, so thank you for your participation. So let me open the Socrative now.